In this video, I want to spend some time talking about our carbide bit insert holders. Now the insert holder is made out of steel and the actual carbide bits will screw to this holder. It depends on how many carbides you have, will change the surface feet per minute, stuff like that. There's a million different types of carbide holders out there. I think we have two different styles. This will be the main style that you will use. I don't know if you can kind of see it. This is like a very general style for steel. We do have an aluminum one, which I will talk about in a later video. You will not use that other one in this class. So if you're using that one, you're doing something wrong. Make sure you're using this one, okay? The reason we're making this video is because we get a lot of these that are damaged. We get a lot of problems where people are running these bits wrong, okay? It is very important that you look at our feeds and speeds section, the section that talks about RPMs for your tool, okay? Make sure you have the correct surface feet per minute, because either I have students running this thing seriously slow or seriously fast. So just make sure you're running the correct RPMs based on the diameter of this cutter, okay? The different types of cutters we're gonna be working with have different diameters. This one's a 3-inch, well, this one's like a 2.5. I think I have a 2 also. But we're gonna be working with all these, so you gotta, every time you switch them up, you're gonna have to change that RPMs, okay? So, a lot of times, some of the other problems we have is one, people have these two machine surfaces dirty when they go and install it in our quill. You wanna make sure these are totally clean. Make sure that quill is all the way up. That way the drawbar can get into this screw. We have a lot of problems where people will jam up this screw. They will wreck the threads at the very beginning. So please make sure that all the way up. Make sure there's no dirt on this. That way it doesn't, impregnate the metal into the sides, and then we have other problems where they're getting stuck in that quill, okay? The other issue is we have a lot of times students will run these backwards. They are directional, so we want to make sure you're going the correct direction. It is pretty obvious which is the correct direction, because as it's spinning around, you want to make sure that these bits are pushing into our piece of metal, okay? If it's glancing off the back, what happens is we actually break all of these bits off. And now I'm going to repeat this probably a couple times in this video. These bits are just held on by a screw. Now the bits cost about 15 bucks and the screw costs about $5. So if this one, which has 5 bits, was to be ran backwards, it will break every single carbide and it will break every single screw. So the cost just to run this one backwards for like 2 seconds, literally you bump it into that piece of metal running backwards and they are done. Costs about 100 bucks. That's a $100 accident right there. The other thing that comes with that is if you run it backwards, you're gonna break all that. You can't just walk away from it. You have to fix it. So I want you to pay extra attention on how to be running these things. Make sure you're running the correct direction. It gets a little bit confusing. I know that forward and reverse, especially when you're high and low, gets a little bit confusing, and accidents do happen, but we need to try to minimize them as much as possible. And again, if you break it, you fix it. So at the end of this video, I'm going to show you guys how to change bits, how to get, and also how to extract those broken screws. Very important that you take care of a problem, because we do not want to put that onto another student. Okay? It is also important how we handle this. We can break a lot of carbide bits just by setting this thing down like this on a flat surface, a flat, hard surface. You've noticed there is some wood surfaces in the machine shop area. That is so that you're able to set things like this down. You're able to set machine surfaces down on it without damaging them. We don't like hard surfaces hitting each other, okay? So do not set this thing straight down. You will break those carbides. I literally also wanted to show you guys a broken carbide for this video. So I broke one, and they break very easy. They are super hard, but also super brittle. So never set it down like this, and never set it down on its side like this, because you could not only damage these machine surfaces, but you could break those carbides. There is, I should say, a nice holder in our machine shop area for you to set it down in like this, and those should never make contact with anything. Do not set boxes on top of it. Do not set other tools on top of it. You need to take care of these. Again, these are very expensive. The bits alone, like I said, were $100, but the actual cutter itself is around $300, and this piece here is about $100, and this is just the attachment that bolts it in there. So we need to take care of these guys. So let's move on. I want to show you guys how to replace a bit. I want to show you some of the tools that we're using, and then I'm going to show you how to extract screws. The first tool that you're going to be using quite a bit is going to be this Torx screwdriver. The Torx screwdrivers are located in the blue bins in the first little room as you walk through. That's also where all the carbides are located. So we have our carbides. They are Kennametal carbides. Make sure they are the correct ones for the tool that you're working on. I'm going to go ahead and I'm going to link the number for these carbides below. These are not the only one we use, but the main one we use. So make sure you have the correct carbides for the tool. The easiest way to make sure that is if they don't match the ones that you broke or that are damaged on the tool already, don't put different ones on. It's really pretty simple. But I will link those below. The screws, if you break screws, again, are also in that same drawers. I believe they're in the lathe drawer because they're used for multiple things, but they are in there. So you can replace those if they get broken. Again, I will link the part number for the screws, and I will also link the part number for this tool. I believe it is a DT7IP, okay? You will use this one quite a bit. Do not get an Allen wrench and try to shove it in. Do not get a smaller Allen wrench and try to make it work. You will strip out that screw, and it's actually harder to get a stripped out screw out of these heads than it is a broken screw. So please take the time, get the right tool for the right job. So let's go ahead and let's replace some carbide ends, and then let's extract some screws. So this is our carbide holder, and I wanted to just get a little bit closer look at it so you can actually see these are our carbide inserts right here, and then that is our screw in there. And then you can also see, let's see if I can show you this. This is the Torx bit that we're going to use. So a lot of times you're going to find these things where they have been either damaged, and I have a damaged one right here. See how this tip is no longer sharp. So this is a bad one, while this would be a good one, okay? Now, oftentimes these will also get dull over a lot of use, or they will have very small cracks in them, or very small chips. So this one is a very defined chip. Like, we can obviously tell that this one is garbage. So to change these things out, all I'm gonna do is take my Torx bit, and I'm going to put it in and just unscrew it out, okay? It is important not to over tighten these things. They need to be snug and tight, but they don't need to be deathly tight. Like I said, these are about $5 a piece, and they can be easily broken. A lot of times these carbide bit inserts are double-sided. We can see that this side is still good while that side is broken. So we're just gonna take this thing and flip it around. So one of the important things to do is to take your actual holder here and make sure there's no dirt on the landing for where that bit needs to go, okay? And we're just gonna flip it over so you can now see that the bad side is up in the tool. And we're gonna take our screw, oops, let me put that in there a little bit better. Take our screw, set it in there. And just screw it down. All right, so that's kind of how to inspect, but also how to just easily swap it out. A lot of times you're going to see, I want to notice one of the screws on this was actually stripped out, but be careful, don't let them strip out, then because this screw will not, or this screwdriver will not work on them. So be very careful about that. Another thing that's very common, like I said before, is very common to have these things break. You can see this one has actually broken, and then somebody tried to use it instead of fixing it. So this creates a big problem, but it's not really that hard to pull these screws out. So you will be responsible for pulling these screws out, or if you find one that is broken, you will end up having to take it out too. So just go ahead and kind of get that in your head that you will have to fix these things probably at least once. We're going to take a pick holder, or an O-ring pick, and we're going to get it out. Most of the time there's no actual tension on one of these screws, so all we got to do is rotate it, and we just take a pick here and we rotate it around, okay? So like I said, you can see that this one is in there, and I'm just going to go ahead and I'm going to try to rotate it. And this is a little bit hard to do on camera. Let's see if I can get it going. Oh, there it goes. So, hopefully you can see that thing is spinning and coming further and further out. Come on. a lot harder to do on camera than I thought it was going to be. Sometimes, and then after it gets out a little bit, it's almost easier to use your finger just to kind of spin it a little bit, because there's really not a lot of torque on that. This one's a little bit hard to get on because it's kind of got a funky shape to the brogue. You can see it's already starting to come out. It's already starting to come out of there. And the reason there's no tension on it is because this is an open hole, so it never has any tension on it. But that's why I say if you get one of these stripped, there's still tension on it, so it's actually a little bit harder. So you can see here's our screw, came right out. Now we would just go and we would get a new hole or new carbide, put it in there, and you're done. But please do not do this kind of stuff where this one has been damaged because somebody ran it and didn't fix it. We're going to try to run this one and see if we constantly have problems with carbide breaking, because now it doesn't have the proper support that it did before. So please just take care of our equipment, please take care of our tools, so that way they last really a long time and more people can use it and we can keep those shop fees down. So I hope that answers most of the questions about carbide bit insert replacement, fixing, stuff like that. All the tools should be able to be all these kind of tools, and all of our holders with our screws and our carbide bits should be located in the green bins in the blue bins in the front room, so you should be able to access them very easily. If you cannot get one out, like you have fought with it and you cannot get it out, please bring it to an instructor. We'd love to help you guys get these screws out, but we just can't keep up on all the maintenance on these guys, so we need your help. Let me know if you have any questions. Please just make sure you pay attention to those feeds and speeds, and also the direction that you are spinning these guys in, because those are how the biggest accidents happen, and you guys should be fine. So good luck, keep moving on.